The topic is conversion of deterministic finite automata to regular expression. The conversion of finite automata to regular expression is possible with three different methods. First one, regular expression equation method, Rij raised to the power k. Next, Adam's theorem, and last one, state elimination techniques. Coming to the first type, regular expression equation method, Rij raised to the power k. Here these two formula is very important. We are going to use it in the Rij raised to the power k equation problem. First one, L of m equal to union of q in f Rij raised to the power k. Second equation, Rij raised to the power k equal to Rij raised to the power k minus 1 plus Rik raised to the power k minus 1 into Rkk raised to the power k minus 1 whole star into Rkj raised to the power k minus 1. This is the basic formula and we are going to use this formula in the problem. I have written a lot of formulas, although you don't need to memorize all the formulas in it. There is an identity rule for this. Using this identity rule, we can form the basic formula. I have written 52 basic formula which I know and 27 formula in identity rules for your consideration. Before moving to the first problem, you should know the basics. When k equal to 0, there are two cases, case 1 and case 2. In case 1, I not equal to j, whereas case 2, I equal to j. In case 1, if there is no such symbol, then Rij raised to the power 0 equal to null, because there are two states ij, there is no transition, then you put null here. So Rij raised to the power 0 equal to null. If there is exactly one such symbol a, then Rij raised to the power 0 equal to a, because there are two states, there is a transition from I to j is a. Then Rij raised to the power 0 equal to a. If there are symbol a1, a2 up to ak, that label arcs from state I to state j, then Rij raised to the power 0 equal to a1 plus a2 plus a base k. Coming to case 2, I equal to j, there is a state I, there is no transition, then how do we write Rij? Rij raised to the power 0 equal to epsilon, because there is no transition here. Next one, state name I, there is a self loop a, then we need to write Rij raised to the power 0 equal to epsilon plus a, because only we are having the self loops, but we need to include epsilon. So epsilon plus a. And third one, state name I, self loop a1, a2 up to a base k. Then how do we write Rij raised to the power 0 equal to epsilon plus a1 plus a2 plus up to a base k. Here there are two cases. In case 1, I not equal to j, which means different states. Whereas case 2, I equal to j means single states. That's why we are writing the rules in the basics when k equal to 0. Coming to the first problem, construct the regular expression from given finite automata. In this finite automata, we have two states q1, q2. There are two inputs. Number of states k equal to 2. How I write k equal to 2? In this transition diagram, we have two states. So k equal to 2. So k takes the value starting from 0, 1, 2. Now we need to find out the regular expression using the two equations. The first equation, L of m equal to q in f Rij raised to the power k. Q in f, which means here we have two states q1 and q2. Take the numbers 1, 2. Here base value 1, 2 and raised to the power k value. K value would be 2. So R base 1, 2 raised to the power 2. The first equation is completed. Second one, Rij raised to the power k equal to Rij raised to the power k minus 1 plus Rik raised to the power k minus 1 into Rkk raised to the power k minus 1 whole star into R base kj raised to the power k minus 1. Coming to the first step, in first step, when k value is 0, how do we find out k value is 0? Take the combination using the transition diagram. In this transition diagram, we have two states q1 and q2. How to take the combinations? R11. Here R11, R12, R21, R22 and k value is 0. So R11 raised to the power 0, R12 raised to the power 0, R21 raised to the power 0, R22 raised to the power 0. We already seen the basic rules when k value is 0. Look at the transition diagram. Here R11 raised to the power 0, which means here there is no transition. R1 there is no self loop. Then we need to epsilon using the basic rules. Here when I value equal to j, because a state is I, there is no transition. Look at the transition diagram. In this transition diagram Q1 there is no self loop, then we need to include epsilon. So R11 raised to the power 0. R11 raised to the power 0 is epsilon. Then next combination is R12 raised to the power 0. R12 raised to the power 0. Look at the transition diagram. R12 there is a transition 0. Then we need to include 0 here. So R12 raised to the power 0 equal to 0. Next combination R21 raised to the power 0. R21 raised to the power 0. In this transition diagram R21, here 2 is there and 1 is here. So 2, 1, there is no transition here. Then you put null here. Here null. Next one R22 raised to the power 0. R22 raised to the power 0. Look at the transition diagram. R22, there is a self loop 1. Then we need to include epsilon as per the theorem. Here there is a state I, self loop A, then we need to include epsilon plus input symbol is A, epsilon plus A. Similarly, we need to write R22 raised to the power 0, which means here self loop is 1. Then we need to include epsilon plus 1. Look at the first step. Here I am writing epsilon plus 1. Coming to the second step, when k value is 1, when k value is 0, we need to follow the basic rules. When k value is 1 or 2, 3, then you should follow the equation Rij raised to the power k equal to Rij raised to the power k minus 1 plus Rik raised to the power k minus 1 into Rkk raised to the power k minus 1 whole star into R base kj raised to the power k minus 1. Only we need to follow the rules when k equal to 0, then we should follow the basic rules. When k equal to 1, 2, 3, then we need to follow the second equation. The second equation would be Rij raised to the power k equal to Rij raised to the power k minus 1 plus Rkk raised to the power k minus 1 into Rkk raised to the power k minus 1 whole star Rkj raised to the power minus 1. Then Rij, here take the combination using the transition diagram. In this transition diagram, the combination is R11, R12, 21 and R22. So take the first combination R11 when k value is 1. Here I am writing raised to the power 1. Rij, here R11 is your ij value and raised to the power 1 is k value. So I and j value would be 1, 1. K value we already written. K value is 1. So 1 minus 1 is 0 plus R base kk. So k value we already know that 1. So R base 1, 1 raised to the power 0 because k values would be 1. 1 minus 1 0 into R base kk. K value is 1. So 1, 1 raised to the power k minus 1. 1 minus 1 0 whole star. Next Rkj. K value is 1 and j value here 1 because here R11 means first one I value and j value. So k value we already know that k equal to 1. So R base k 1, j value would be 1 raised to the power k minus 1, 1 minus 1 0. We already written the value r11 raised to the power 0. We need to include the epsilon value. Here I include epsilon plus here r11 raised to the power 0 epsilon. r11 raised to the power 0 is epsilon whole star. Again r11 raised to the power 0 epsilon. Next epsilon plus epsilon into bracket of epsilon raised to the power star, whole star. Here r star equal to r star. Then how do we write here epsilon whole star, which is written as epsilon. So here I am writing epsilon whole star is epsilon. So epsilon into epsilon. Next step, epsilon we can write it as epsilon. Finally you will get epsilon. So r1 raised to the power 1 equal to epsilon. Next combination is r12 raised to the power 1. Here I value is 1, j value 2. Here apply the formula. We already know the formula is rij raised to the power k, rij raised to the power k minus 1, rik raised to the power k minus 1 into k r base kk raised to the power k minus 1 whole star into r base kj raised to the power k minus 1. Coming to the combination r12 raised to the power 1. Here I value is 1, j value is 2. First one, rij raised to the power k minus 1. rij, here I value is 1, j value is 1. So r base 1 2 raised to the power 0 plus next one is rik. Ik means I value is 1, k value is 1, raised to the power k minus 1 means 0 because k value is 1, 1 minus 1 0 into r base kk raised to the power k minus 1, k value is 1, so 1 1 raised to the power 1 minus 1 0 whole star into r base kj. Look at the formula, r base kj raised to the power k minus 1. Here k value is 1, j value would be 2, r12 raised to the power k minus 1 means 0, r12 raised to the power 0. Look at the first step. In the first step, r12 raised to the power 0 is 0, r12 raised to the power 0 is 0 plus r110 is epsilon. See the first step, r11 raised to the power 0 is epsilon. Here I am writing epsilon. Again r11 raised to the power 0 is epsilon whole star. Then r12 raised to the power 0 is 0 because we already written r12 raised to the power 0 is 0. Here you put 0. So 0 plus epsilon into epsilon whole star. Here r star equal to 0 as per the identity rules. Epsilon r star means r. So epsilon star is which is written as epsilon, then put 0 here. Epsilon 0 is 0. So 0 plus 0 is 0. R base 1 2 raised to the power 1. The value would be 0. Next combination is r21 raised to the power 1 equal to, here as per the formula, I value is 2, j value is 1 raised to the power 1 equal to rij raised to the power 0. I value is 2, j value is 1. So r21 raised to the power 0 plus as per the formula, here look at the formula, rik raised to the power k minus 1. rik, I value is 2, k value is 1 raised to the power 0 because k values would be 1, k minus 1 0 into rkk raised to the power k minus 1, k value is 1, 1 raised to the power 0 whole star. Next rkj, k value is 1 and j value here 1 raised to the power 0. r21, look at the first step. In the first step, r21 raised to the power 0 is r21 raised to the power 0 is null plus r21 raised to the power 0 is null. Then r11 raised to the power 0, we already written epsilon raised to the power star r11 raised to the power 0 epsilon. Here epsilon plus, if any value multiply with null, you will get null. So null plus null equal to null. And next combination is r base 2 raised to the power 1. This is the last combination. I value and j value would be 2. Here as per the equation, r base ij means I value 2, j value 2. So 2 base 2 raised to the power k minus 1, k value would be 1, 1 minus 1 0 plus rik. Look at the formula here, rik raised to the power k minus 1, rik raised to the power k minus 1. I value is 2 here, j value k value already 1, raised to the power k minus 1 0. Next r base kk raised to the power k minus 1, k value would be 1. So r base kk raised to the power k minus 1 0 whole star. Next rkj, k value would be 1, j value would be 2. So r12 raised to the power 0, r22 raised to the power 0. Look at the first step. In this first step, r22 raised to the power 0 equal to epsilon plus 1. Here I am writing epsilon plus 1 plus r21 raised to the power 0. Look at the first step, r21 raised to the power 0 is null. Here you write null, r11 raised to the power 0 is epsilon. Here r11 raised to the power 0 equal to epsilon. Here you write epsilon whole star r12 raised to the power 0. r12 raised to the power 0 is 0. Here 0. Then epsilon plus 1, then if you multiply with null, you will get null. Epsilon plus null, epsilon plus 1 plus null, you will get epsilon plus 1. So we finished when k equal to 1 part. Then move to the next step when k equal to 2. As per the equation, when k equal to 2, k equal to 2 means, look at the first step. In the first step, L of m equal to r12 raised to the power 2. Here k value would be 2. Then we need to find out directly r12 raised to the power 2 because the k value is 2 here. So r12 raised to the power 2. We no need to find out r11 raised to the power 2 and r21 raised to the power 2, r22 raised to the power 2. Only we need to find out r base 12 raised to the power 2 because in this first equation we already know that L of m equal to r base 12 raised to the power 2. So you directly find out the answer using the step r base 12 raised to the power 2 equal to, here rij raised to the power k minus 1. What is your ij value? Here I is 1, j value is 2. So r base 12 raised to the power k minus 1. K value is 2. So 2 minus 1, 1 plus rik. I value is 1 and k value is 2. R base 12 raised to the power 1 because k value is 2. 2 minus 1, 1 into r base kk. K value is 2. So r base 2 raised to the power 2 minus 1, 1 whole star. Next rkj. K value is 2. R base k. J value is here 2. So k value 2, j value 2. R base 2 raised to the power k minus 1, 2 minus 1. R12 raised to the power 1. Look at the first step. In the first step, R12 raised to the power 1 is 0. Here you put 0. Next plus R12 raised to the power 1 is 0. Into R22 raised to the power 1 whole star. R22 raised to the power 1. Look at the first step. Here R22 raised to the power 1 is epsilon plus 1. Here I am writing epsilon plus 1 whole star into r base 22 raised to the power 1 is epsilon plus 1. Then how do you simplify this equation? 0 plus 0, next epsilon plus 1 star. Using the identity rules, epsilon plus r raised to the power star equal to r star. So epsilon plus 1 raised to the power star equal to 1 star. Here I am writing 1 star. Remaining epsilon plus 1. Next identity rule, r star epsilon plus r equal to r star. So 1 star epsilon plus 1 raised to the power star equal to 1 star. Then we can easily write 1 star here. So 0 plus 0 1 star, that is as per the identity rules, r plus r star equal to r star. Then we can get 0 1 star. So finally you will get the answer r base 1 to raised to the power 2 equal to 0 1 star. So your final regular expression going to be 0 1 star. Coming to the second problem. In this second problem, construct the regular expression from the finite automata. In this transition diagram, we have two states. In the first state, we have self loop 1 and there is a transition from Q1 to Q2 0 and here Q2 having the self loop 0 comma 1. We are having the two inputs 0 1. How do you solve the problem? Number of states. Look at the transition diagram. In this transition diagram, we have two states. So k value would be 2. So k takes the value starting from 0 1 2. Now we need to find out the regular expression using the two equation. We already know the two equations. L of m equal to union base q in f rij raised to the power k. So here q in f means there are two states q1 and q2. So 1 2. So base value 1 2. Two states means here k value would be 2 raised to the power 2. So L of m equal to r base 1 2 raised to the power 2 and second equation is rij raised to the power k equal to rij raised to the power k minus 1 plus rik raised to the power k minus 1 into rkk raised to the power k minus 1 whole star into rkj raised to the power k minus 1. Coming to the first step, when k value equal to 0. When k value is 0, we need to follow the basic rules. Because there are two cases, we already seen these rules. Now, when k equal to 0, using the transition diagram, take the combination using the transition diagram R11, R12, R21, R22. So, R11, there is a self loop 1. So in this transition diagram, when you are going to find out the regular expression, we should follow the basic rules. Here the basic rules are I equal to j. Here a state having the self loop, we need to include the epsilon. In this question, q1 raised to the q1 self loop 1. Here R11 raised to the power 0 equal to epsilon plus 1. Because the starting state and final state, we need to include the epsilon symbols. So R11 raised to the power 0. Because k value is 0, we need to follow the basic rules. So as per the basic rules, we need to include the epsilon symbols in the starting state and the final state. Here, in the starting state, R11 raised to the power 0, epsilon plus 1. So because Q1 is having the self loop 1, so epsilon plus 1. Next R12 raised to the power 0, R12 raised to the power 0 means there is a transition from Q1 to Q2 0. Then you write here 0. Next R21 raised to the power 0. Look at the transition diagram. Here R21 there is no transition, then you just put null symbol. Next R22 raised to the power 0. Look at the transition diagram. R22 raised to the power 0. There is a transition, I mean the self loop 0 comma 1. So 0 comma 1, how do you write the regular expression 0 plus 1? I already told you, as per the basic rules, in the starting state and the final state, we need to include the epsilon symbols. So in the final state we need to include the epsilon symbol. Here epsilon plus 0 plus 1. So we got all the combinations value. R11 raised to the power 0 is epsilon plus 1, R12 raised to the power 0 is 0, R21 raised to the power 0 is epsilon, R22 raised to the power 0 is epsilon plus 0 plus 1. Coming to the second step, when k value is 1, we need to follow the second equation, Rij raised to the power k equal to Rij raised to the power k minus 1 plus Rik raised to the power k minus 1 into R base kk raised to the power k minus 1 whole star Rkj raised to the power k minus 1. Here first combination is R11. R11 k value is 1. So R11 raised to the power 1. Here base value is 1 1 and I and j values are 1 1 because I value is 1 and j value is 1. Here I R base ij means base value 1 1 raised to the power k minus 1 means 1 minus 1 0 plus R base ik. I value is here 1, k value 1. So R base 1 1 raised to the power 0 into R base kk. Kk means k value. Here R base kk 1 1 raised to the power 0 whole star. Next Rkj, k value 1, j value is 1 raised to the power 0. We already found in the first step R11 raised to the power 0 epsilon plus 1. Here you write epsilon plus 1 plus epsilon plus 1 R11 raised to the power 0 whole star epsilon plus 1 raised to the power whole star epsilon plus 1. Here epsilon plus 1 plus epsilon plus 1, here epsilon plus 1 whole star. Look at the identity rule, epsilon plus r star equal to r star. Then you directly write 1 star here into epsilon plus 1. Then epsilon plus 1 plus here 1 star epsilon plus 1. How do you write 1 star epsilon plus 1? You have to write as per the basic formula. Here 1 star and remaining portion is epsilon plus 1. So epsilon plus 1 plus 1 star epsilon plus 1. 1 star epsilon plus 1, you directly write 1 star. So 1 star plus epsilon plus 1. As per the identity rules, r star plus epsilon plus r equal to r star. Then you write 1 star here. So R11 raised to the power 1 is 1 star. Then move to the next combination. The next combination is R12 raised to the power 1 equal to here I value and j value. I value is 1, j value is 2. Here as per the equation Rij raised to the power k minus 1. Rij, I value is 1, j value 2 raised to the power k minus 1, 1 minus 1 0 plus Rik, I value is 1, k value is 1 raised to the power 0 into r base kk raised to the power 0. K value would be 1, 1 1 raised to the power 1 minus 1 0 whole star. Next Rkj, k value 1, j value is 2, 2 raised to the power 0. R12 raised to the power 0. Look at the first step. In the first step, R12 raised to the power 0 is 0 here. R12 raised to the power 0 is 0 plus R11 raised to the power 0. We already written R11 raised to the power 0 is epsilon plus 1. Here you write epsilon plus 1. Next R11 raised to the power 0 whole star epsilon plus 1 raised to the power star 0. Here 0 means R12 raised to the power 0 value. We already written here. So 0 plus epsilon plus 1. Epsilon plus 1 star. We can easily write using the identity rules epsilon plus r star equal to r star. So here you write 1 star 0. Then 1 star epsilon plus 1. 1 star epsilon plus 1, you can write 1 star. So here 0 plus 1 star 0. Finally your regular expression is 0 plus 1 star 0 or 0 plus 0 1 star. we can easily write 0 1 star as per the identity rules, or 1 star 0. And next combination is R21 raised to the power 1. Using the formula R21 means I value is 2, J value is 1. As per the second equation, R base Ij, I value 2, J value 1 raised to the power k minus 1 0, plus Rik, I value is 2, k value 1 raised to the power 0 into Rkk, kk means k value 1, so R base k 1 raised to the power 0 whole star. Next Rkj, k value 1, j value is 1 raised to the power 0, R210. Look at the first step. In this first step, R21 raised to the power 0 is null. Here you write null. Next R plus R21 raised to the power 0 null. R11 raised to the power 0. We already written epsilon plus 1 in the first step. In the first step, R11 raised to the power 0 is epsilon plus 1. Here you write epsilon plus 1 raised to the power star, then R11 raised to the power 0 epsilon plus 1. So null plus, if you multiply any value with null, you will get null. Null plus null, null. And last combination is R22 raised to the power 1 equal to I value is 2, J value is 2. So R base Ij raised to the power 0 plus Rik, I value is 2, k value is 1 raised to the power 0, Rkk, k value 1. So R11 raised to the power 0 whole star. Next Rkj, k value 1, j value 2 raised to the power 0. R22 raised to the power 0. Look at the first step. In the first step, we already written R22 raised to the power 0 is epsilon plus 0 plus 1. Here you write epsilon plus 0 plus 1. R21 raised to the power 0. R21 raised to the power 0 is null. Here you write null plus R11 raised to the power 0. Epsilon plus 1. So here epsilon plus 1 raised to the power star, and R12 raised to the power 0. R12 raised to the power 0 is 0. Here I am writing R12 raised to the power 0 is 0. Then epsilon plus 0 plus 1 plus, then you multiply with any regular expression with null, then you will get null. Then finally you will get epsilon plus 0 plus 1. So R22 raised to the power 1 is epsilon plus 0 plus 1. Coming to the next step 3, when k equal to 2. When k equal to 2, look at the question. In this question, R12 raised to the power 2. When k value is 2, you directly find out R base 1 to raised to the power 2. You no need to find out R11 combination or R21 combination R22, because in the first step we already found L of m value. Then you directly find out the value of R12 raised to the power 2. Here I value is 1, J value is 2 raised to the power 2. So R12 Rij raised to the power k minus 1. I am directly writing here because Rij, R12 raised to the power 2 minus 1, 1. R12, 1. We already found in the previous step R21 is 0, 1 star. Here you write 0, 1 star plus I value is 1, k value is 2. R12 raised to the power 1. So same value 0, 1 star. Then R base kk, k value is 2. So R22 raised to the power 2 minus 1, 1. R22 raised to the power 1. Look at the previous steps. Here R22 raised to the power 1 is 0, epsilon plus 0 plus 1. Here you write epsilon plus 0 plus 1 raised to the power star. Then Rkj, k value is 2, j value is 2. So R22 raised to the power 1. Similarly, epsilon plus 0 plus 1. In this regular expression, the common term is 0, 1 star. You take it out 0, 1 star. Then epsilon plus epsilon 0 plus 1 whole star, epsilon plus 0 plus 1. As per the identity rules, epsilon plus r star, you can directly write r star. Here I am writing epsilon plus 0 plus 1 whole star. Then epsilon plus 0 plus 1 star, as per the identity rules, epsilon plus r star is r star. Then here you write 0 plus 1 star, then remaining is 0 1 star. Finally, you will get the regular expression r12 raised to the power 2 equal to 0 1 star of 0 plus 1 raised to the power star. This is your final answer. Coming to the third problem, in this third problem, construct the regular expression from finite automata. This is the transition diagram. So here number of states k equal to 3 because we have 3 states q1, q2, q3. So k value would be 3. K takes the value from 0, 1 to 3. Now we need to find out the regular expression using these two equations. L of m equal to q in f, union of q in f, Rij raised to the power k. Here starting state is q1 and final state going to be q2 and q3. Previous problems, look at the previous problem. In this previous problem, the starting state is q1 and the final state is q2. In the second problem, starting state is q1 and q2. There is only one starting state and the final state is there. But in this problem, one starting state and two final states are there. We need to form the L of m equation. Here starting state is q1 and final state q2, q3. So here take the combination r1 2 r13. So r12 k value would be 3. So r base 1 to raised to the power 3 plus and next starting state and final state. Because we have two final states, here starting first combination is r1 2. Here I am writing r base 1 to raised to the power 3 because k value is 3 plus starting state q1 and next final state is 3. R base 1 3 raised to the power 3. So we easily find out the L of m value. R12 base raised to the power 3 plus R base 1 3 raised to the power 3. When k value is 3, only we need to find out the value R base 1 2 raised to the power 3 plus R base 1 3 raised to the power 3. And next equation is R base ij raised to the power k equal to R base ij raised to the power k minus 1 plus R base ik raised to the power k minus 1 into rkk raised to the power k minus 1 whole star R base kj raised to the power k minus 1. Coming to the first step, in the first step when k value is 0, I already told you when k value is 0, we need to use the basic formula. Using this basic formula, we need to frame the regular expressions. So R11 0, how do you take the combinations here? Using the transition diagram. In this we have three states, so we take the possible combination R11 raised to the power 0, R12 raised to the power 0, R13 raised to the power 0, then R2 raised to the power 0, R22 raised to the power 0, R23 raised to the power 0, then R31 raised to the power 0, R32 raised to the power 0, R33. So the first combination is R11 raised to the power 0. Look at the transition diagram. Here R11, there is no self loop. We need to include epsilon because as per the basic rules, take the case I equal to j, because I equal to j means single states, I not equal to j, which means different states. In this transition diagram, there is no self loop here, but we need to include epsilon. So R11 raised to the power 0 equal to epsilon. Next R12 raised to the power 0. Look at the transition diagram. R12, there is a transition 0. Here you put 0. Next R13. Look at the transition diagram. R13, there is a transition 1. Here I mention the value 1. And next combination is R21 raised to the power 0. R21. 2 1 there is a transition 0, here you include 0. r22 raised to the power 0, r22 raised to the power 0, there is no transition, but we need to include the epsilon as per the rules case 2 I equal to 0, because single state there is no self loop, we need to include epsilon. Next r23 there is no transition here, there is a transition from 1 because Q2 to Q3 is 1, we need to include 1. Next R31, see the transition 3 1, there is no transition, then we need to include null symbol because there is no transition 3 1. Next 3 2 0 1, so how do we write the regular expression? 0 plus 1. Next R33, look at the transition diagram. In this transition diagram there is no self loop, but we need to include the epsilon as per the basic rules. R33 raised to the power 0. Here I found the first step, and remaining steps when k equal to 1, k equal to 2 and when k equal to 3, you should find r1 r base 1 2 raised to the power 3 plus r base 1 3 raised to the power 3. When you get the answer, you just post it in the comment box. If you have any doubts about the problem mentioned so far, comment in the comment box. Thank you.